All right, good morning all. So remember what we have done in our previous class. So basically for our friends who weren't there, let me just do a quick recap because we're going to move on. So basically what we did is remember our demand curve, right? So the regular demand curve. So basically we had demand curve, don't forget that demand curve actually shows the optimal points, right, that you choose, basically. So what we did is you have seen this, but for instance, let's say this is, let's call this E1, let's call this, let's say, X star. Suppose I keep decreasing price, so Px is greater than Px prime, greater than Px double prime, okay? Suppose price is Px here. And then we said that, so we were trying to derive the demand curve. So it's going to give us the relationship between price of X and X, okay? And then we said that when Px is Px, price of X, then the optimal amount is X star, right? So we called it E1. And then we said that let's decrease this price. And then you guys told me that, oh, hocam, it's going to tilt our, bless you, budget constraint like this, because now, and then we actually look for the new optimal point. Let's call this E2. This is going to be X double star, let's call this, okay? And then when price is Px prime, it's here, we said E2, this is the optimal point, and X star, right? And we do this, we do it for, let's say, another point, right? So we did this, and then we have this, so this is E3, okay? And this is going to be X triple star, okay? Now, and when we have Px double prime, so let's call this E3, okay? And then we connect all these points. Suppose you do this for every possible price, and then the curve that you get, okay, we called it uncompensated demand curve, Marshallian demand curve, ordinary demand curve, which was a function of Px, Py, and I, okay? And you guys told me that, oh, hocam, along this curve, we keep income of the consumer the same, Py of the other good the same. The only thing that is changing is Px. But then, you guys told me another thing, hocam, even though it might not look very obvious, like here, but what happens that as we move along this curve, what else is changing? You said that? Utility, right? So you said that, hocam, from at E1 you have, let's say, U1, U2, U3, okay? So you see that when I move from E1 to E2 to E3, actually utility level is also changing. So here we keep nominal income constant, constant, but what's happening is that real income changes, right? But utility, or you can call it real income, changes along X star, Px, Py, I, okay? And then we said that, so this is the case. Then we said that this was called compensated demand curve. Uncompensated, sometimes called ordinary, sometimes called Marshallian, okay, demand. Now, this was the case. And then we said that, well, we can do the similar exercise because we now figured out what's going on. Like this, we can say that, well, here I'm keeping I the same, but what if I don't keep I the same, but I want to keep utility, the same, and I want to keep the consumers compensated for any changes, positive compensation or negative compensation, for any change in price, so that the individual is always going to achieve U bar, utility level U bar, okay? This was leading us to the compensated demand curve. Compensated, sometimes called Hicksian, demand, okay? And then, so this idea, and we said that, well, it's going to be something like this. We have this. So this is actually part of the stuff that we have done before, so that you guys actually won't be too sort of far away from what we have done, okay? So basically, here we have the compensated demand curve. For instance, I said, let's consider, suppose we have here, suppose this is px prime divided by py, and suppose here I have u2, here I have e2, this is x star, right? And then let's actually have this. Again, I want to have a relationship between px and x, but I'm holding other different stuff constant here. Now I said that this is px prime. When it's px prime, we have this x double star. And I'm going to call this x double star here, x double star c equals to x double star c, meaning that at this, you know, like suppose this is utility level u bar. So if you want to, so at this point, you know, like the compensated demand and the ordinary demand curve, they are the same, right? Because income is just enough to achieve this utility level, and with that income, you can achieve this utility level, and in order to achieve this utility level, you need, the minimal income you need is I, okay? But then, as we keep, for that price, right? So, but as we keep changing price, you told me that, oh, hocam, for instance, if you decrease the price, let's say px double prime, what's going to happen? When you decrease the price, the guy is going to feel better off or worse off? When price decrease, better off, right? So the guy would feel richer, but remember, I'm not going to let the guy to feel richer. I'm going to keep the real income utility level the same. I'm going to get some money from the guy such that the guy would still be on the same, so let's call this C2, on the same utility level. So let's say it's something like this, okay? So here you can say that the slope minus px double prime py, okay? And then I'm going to call this x triple star c. And then you guys told me when price decreases, it's this point. So this is E2, which is equal to C2. I'm going to call this C3. And you guys told me, is this the same as x triple star there? No, right? You told me that, hocam, no, because what happened is that I got some money from this guy. So this is going to be smaller or larger than that guy. X triple star. Smaller, right? Because you didn't let the guy enjoy the full, like benefits of the decrease in price, right? So we said that this is not equal to x triple star. And then we actually said that, so similar exercise, you can do it here. Sorry, so you can do it. So suppose I increase the price. This time I need to give money to the guy, or I should get money from the guy? I should give money to the guy, right? So x star c, let's call this x star c. And then this is c1, right? And this is going to be px double prime. So it's here, let's call this c1. And when I connect all these points, if I keep doing this exercise, I'm going to get what we call the compensated demand curve. On this, we know that we keep the utility level the same, but what is changing, if you say? If I move from C1 to C3, what is changing? Right now, the nominal income changes, utility stays the same. Okay, so I just say that utility, real income stays constant, okay? But nominal income changes, because remember, I keep compensating the guy, changes, okay? So this is another way of expressing the idea of a demand curve, right? Holding some other stuff constant, looking for the relationship between this guy and this guy, okay? So this is what we said. So basically, these were the two demand curves that we have seen, okay? And then remember, and then this is this guy, is smaller than that guy or larger than that guy? X star there. X star C is larger, right? Because now you give money to the guy, so compared to that case, the guy can enjoy a little bit more X, right? So because you made the real income decrease go away, so that the guy can actually consume a bit more, okay? So again, this is not the same as X star. And then you guys told me, what is the relationship between these two demand curves? You said that Px over X. Suppose I draw X star, Px, Py, I. I keep these guys the same. How shall I draw the compensated one? Is it steeper or flatter? Steeper, right? So you said that, hocam, it should be steeper. You can easily argue from here when price increases, this is going to let you to consume more, right? So when price increases, it should correspond to a higher level, right? So this compensator. When price decreases, it should correspond to a lower level. So it should be steeper, right? So this you can call it like E2 equals to C2. And then, so this part, you would say that, hocam, this is the case, U bar, okay? And then, so it's the compensated demand curve is steeper, right? We can actually say this from other dimensions as well. So remember you guys told me that on this compensated demand curve, because we keep compensating for the changes in real income, do we see income effect? On the compensated demand curve? No, right? So we don't see the income effect. We see only substitution effect. That's what we said. So that's why if you think about it, and remember in the last class we said that substitution effect is always, what was that derivative? So apparently, remember we said that this is going to correspond to the substitution effect. And we know that this guy was always negative, right? So that's why, but this guy, and then, so we can actually write down. So once we figure these guys out, we learned about an important relationship between the slope of the compensated demand curve and the slope of the ordinary demand curve. And we called it Slutsky equation, okay? So, which was something like this. So it was basically the relationship between, it was giving us the relationship between these slopes of these two demand curves, right? And then we called it X star del I times X star, right? So this is called the Slutsky equation. Apparently that's the correct pronunciation in Russian. So who knows Russian? You know? Okay. So it's, I don't. So, but you see that this is actually, so this was, and we derived it basically using the fact that at this point these guys are the same, okay? XC and X star are the same. And then we arrived this equation, but you see that we can see it here as well. We actually showed that this guy is always negative and this corresponds to the substitution effect, okay? And then we saw that this guy is the income effect with the minus sign, okay? Don't forget, so this is the income effect, right? So you see that when you consider the slope, this ordinary guy has two components in its slope, right? It has a substitution effect, but it has the income effect as well, okay? And this guy, if it's a normal good, what did we say? This income effect is, if it's a normal good, this is what? When income increases, do I increase my consumption of that good or decrease my consumption? Increase, right? So this is positive if it's a normal good. This guy is positive as well. So if it's normal, then this income effect is going to be positive, right? If it's normal. So you see that income effect is kind of decreasing the slope, right? So it's kind of getting rid of some portion of this negativeness, right? So that's why compensated demand curve is steeper and the ordinary demand curve is actually flatter, okay? So, but you should think of it as you know, like for a normal good, we wrote it like this, okay? If it's not a normal good, then remember the analysis that we are doing here is not going to be valid, right? If it's not a normal good, then if it's an inferior good, this is going to be what? So it's going to be positive if normal. But if it's an inferior good, you would say that, oh, hocam, this is positive, but this is negative. So overall,
but there's a negative sign.
Oh, yeah, sorry. So what did I do? This is positive, yeah. So this is negative, right? So let's put it like this. So it's going to, income effect will be negative if it's normal, so that the effects would go in the same direction, okay? And then if it's an inferior good, then this is going to be positive. Income effect would be positive if it's an inferior good, okay? But don't forget that, so don't get confused. But don't forget that the slope that I'm having here is actually the inverse of the slope, okay? So that's why the compensated demand curve being more negative here would mean that 1 over this number is going to be smaller in this case, okay? Whereas when it's not more negative, 1 over that number is not going to be that small, so it's going to be steep, okay? So don't forget the fact that this here, the slopes of these curves are basically, it's actually this, right? And this, okay? So just keep that in your mind. Remember, we said that actually the one that we draw here is not exactly the demand curve, but it's the inverse demand curve, okay? So basically, it's the case. So you can, if you want to derive it, you can also derive it from the Slutsky equation, okay? Now, yes?
Şurada inferior kutular için income efektin mutlak değerinin substitution efektten küçük olduğunu, büyük olduğunu nereden biliyoruz?
So that we don't know, of course. So as you are saying that if it's no, he's right. So in this case, we don't know, right? So it's the inferior case. If income effect, right? So the absolute value of the income effect is less than the absolute value of the substitution effect, then it's going to be, right? So this is going to be overall, this guy is going to be negative, right? If that is not the case, overall, that guy is going to be positive, okay? But this is okay. So I'm talking about income effect. So this, whatever I wrote was right, okay? Income effect is always positive when it's inferior, but if it's more positive than this guy, then it's going to make the slope upward sloping, okay? So this is what we have discussed. So we can actually say if income effect is less than the substitution effect, we said, so let's call this the total effect, okay? So the total effect is going to be, would be, we said negative, right? If income effect is greater than the substitution effect, then the total effect would be positive. And this case corresponds to Giffen good. Okay, is that clear? Corresponds to the Giffen, but it doesn't affect the sign of the income effect, right? If it's inferior, the sign of the income effect would be positive, okay? So just keep this in your mind. It's actually very important. We're going to use the Slutsky equation. We're going to use compensated demands and regular demand curves a lot. So I try to give a quick recap for our friends who weren't here, okay? Now, remember we were dealing with this concept of these slopes, right? And we figured out that we have to be a little bit careful because the slope of this curve that I have drawn here is del px over del xc. The slope of the demand curve is del xc over del px, but as long as it's continuous, we can actually use them interchangeably, right? So one over the other one, it's going to be the case. But suppose I want to, so let me ask you this. Suppose I want to know, so let's actually have this. Suppose I want to know this, right? So I'm interested in this guy. So this is basically when I increase the price of, let's say, caramel macchiatos at Starbucks, how would the consumption of, right, demand so quantity demanded of caramel macchiatos change, okay? So this is something that I want to figure out. Suppose I measure caramel macchiatos in liters and I have a demand curve like this. So I'm going to write here price of X, I'm going to write here X. So in liters, this is caramel macchiatos, okay? And suppose we have a demand curve like this. So let's say this is 14, this is 4, this is 20, okay? So this is per liter price of caramel macchiato, okay, let's say, okay, for per liter. And this is actually, right, a point on this demand curve, okay? So if I want to know this, when price of X changes, what is the change in caramel macchiatos? So what is this guy? So it's basically this guy, but this is the change in PX. So how much is this? This is 20, right? Here it's 10. So its change in X is 10, change in PX is 20. So this is 0.5, right? So we say that when there's a change in price changes by, let's say, 1 unit. The amount of caramel macchiatos, they would change by 1/2 units, okay? Now, suppose I got bored. I said I want to measure everything in centiliters, okay? Now, let's just keep this in mind that this guy is in what? This guy is in, what's the unit here? Liters, right? What is this guy? This is Turkish lira per liter, right? So this is TL per liter, okay? Don't forget that we have something like this. Now I want to measure everything in centiliters, okay? So I want to write down the same demand curve. So this is, again, I'm going to give the price per liter. So what's going to happen? So 1 liter is how many centiliters? 100, right? So it's actually, so let me write this. Suppose I have something like this, right? So here, this is going to be 1400. Here, it's going to be 400, right? And then again, this 400, because it corresponds to 4 liters, 20 Turkish liras. Again, here I measure it per liter. Here I measure in centiliters, okay? Now, fine. So what is this guy here? Del X star, del PX. What is this? So here it's going to be 20. Here it's going to be 1000, right? So the change in X is 1000, right? And then the change in PX is 20. This is 50. Okay, so do you think this is a good measure of what's going on? Right, so it's the same information, right? The only thing I did is I converted to centiliters, and I want to figure out when there's a 1 Turkish lira increase in the price per liter, how would my consumption change, right? But here I found 0.5. Here I found, if I look at the slope, here I would find 50, right? And what is so here, this guy is in what terms? Centiliters, right? Here, this guy is in what terms? TL per liter. You see, it's weird. So I cannot compare this guy to this guy, and this could be for different goods, right? I might want to compare the responsiveness of 2 goods, right? Caramel macchiatos and, let's say, saleps. How responsive salep is to changes in price and how responsive to caramel macchiato. Fine, I might both measure them in liters, or I might want to figure out how sensitive the demand for caramel macchiatos to changes in price and how sensitive to demand for automobiles to changes in price, right? Can I measure automobiles in liters? No, right? So what happens is that if you want to figure out, and this is important, you'll see that many of the empirical analysis at the end of the day, they would want to know this. Okay, you're going to have, you know, like some utility maximization problem going on behind, whatever. But at the end of the day, when you go to, or, you know, like all these research agencies, have you heard something called Ipsos in Turkey, right? So it's araştırma şirketleri var. So for instance, Ipsos, at the end of the day, for instance, what Zeynel would like to know, when there's an increase in the price, how would demand respond to that, right? They wouldn't, that would be the number that they want to figure out, okay? Or if Toyota would like to know, if I increase my prices, how would demand respond to that, okay? So at the end of the day, this is going to be what they're interested in, okay? Not the utility maximization problem or whatever, but this outcome, okay? So, but then you're going to, in one case, you're going to report them 0.5. In one case, you're going to report them 50. But it's the same information, right? So that's why we said that in order to measure the responsiveness of changes in price to how it would affect the change in quantity demanded, okay? Slope is not a very good idea because it is not unitless. Yes.
Şurada neden mesela TL bölü litre yazdıkta bana TL bölü santimetre?
Of course, you can, of course, but you know, like it could be, the measure that you should have should be irresponsive of these units, right? So you are right. I can always convert, let me write down this guy in terms of centiliters, but it should be, right? I mean, the measures that you're going to report should be irrespective of, you shouldn't be dealing with converting units, right? Which you can. He's right. So he's like, hocam, you're cheating here. You put this per TL, make it per centiliter. So it should be similar information. But the issue is that we could come up with a measure where we don't have to do this conversion all the time, okay? And so you see that this is not unitless. So apparently slope is not unitless. So it might not be a very good idea. It makes sense, but it might not be a very good idea. What would you guys suggest? Right, so let's suggest this. So when you use absolute changes, this is basically the absolute change. It's problematic because it's not unitless. But when you use percentage changes, then it's going to be, so, you know, one idea is do this. X star del px, okay? And I'm going to put here px over x star, right? Then what's going to happen in both cases? Suppose, you know, that this guy was in liters, this guy was in TL per liters, this guy is going to be TL per liters, this guy is going to be liters, right? So you see that these guys cancel out, or you have the centiliters version. They will cancel out, and it's going to give us, you know, like a unitless number, right? So that we can compare. So what you said would work in this one, but what you said wouldn't work when you want to compare automobiles to, right, caramel macchiatos. In this case, I can convert the prices, but I cannot do it, right? Automobiles, they're measured in 1, 2, 3, 4, 5, right? Sometimes they measure them in kilograms, though, in trade data and such. But you know, like, how are you going to compare these guys? So you need a unitless measure. And as your friend suggested, this unitless measure is actually called the elasticity, okay? So basically, elasticity, it's going to measure the responsiveness of quantity demanded to changes in price, okay? So I'm going to define, and in this course we're going to have different elasticities for both of these demands, okay? So let's see. So let me write these down. So you see that this is this percentage change, this is unitless, so which is good, okay? Now we're going to have two types of elasticities. Elasticities for this uncompensated demand curve and elasticities for this compensated demand curve, okay? So let's write this. The first one is Marshallian demand elasticities. So let me define. So the first one is the classical price elasticity of demand. Okay? So price elasticity of demand, we're going to denote this elasticity x px, okay? This is going to be, you see that percentage change in x star divided by percentage change in px, okay? So percentage change in x star divided by this. So this is going to be, what is percentage change? Percentage change in this guy divided by this guy. Px, change in px divided by px, right? So del x star del px, px divided by x star, right? And then this was actually what you have seen in Econ 101, but now we know what these guys are, right? So this was the baby version. So more formally, we can actually write it like this, right? I divided by del px, px divided by x star, okay? So this is what we call the price elasticity of demand. So it's going to give you, oh, if there's a 1% increase in price, how much quantity demanded would reply, how much your consumption would respond to that, okay? So by what percentage, right? So this is actually price elasticity of demand, and you see that we get rid of the units. Now, there is another one. So people, remember, they were not only curious about when px changes, how x star would change. They were curious about when income changes, how x star would change, okay? And they called it, actually, they would call it income elasticity of demand, okay? So income elasticity of demand, so it's going to be this elasticity of x to I, okay? So similar logic, percentage change in x star divided by percentage change in I, okay? So basically this is going to be del x star, del I. This is going to be del x star, del I divided by x star. So this is going to be basically this, px, py, I, del I divided by x star, okay? So this guy is called income elasticity of demand, and how you're going to basically interpret it. If there's a 1% change in consumers' income, by what percentage, right, consumers' consumption of good X change, okay? So basically this is the case, and there could be another one. So what could be the other elasticity that you can think of, the third one? Right, so it's going to be cross, because I check it with respect to px. I checked it with respect to I. There's actually another one which you would like to know, or what's going to happen if the price of the other good changes. And that's going to be the third one, and we call it, as you guys said, cross price elasticity, right? So cross price elasticity of demand. So this is basically, let's write this. The third one is what we call the cross price elasticity of demand, okay? So it's going to be the cross price elasticity of demand. So it's basically this, but py, okay? So again, the similar idea, percentage change in x star with respect to a percentage change in py. So this is going to be x star del py over py del x star over del py over x star. I divided by py divided by x star, okay? So this is basically when the price of the other good changes by 1%, how would consumption of x respond to that, Okay, so this is basically the case. Now for our friends who doesn't know price elasticity of demand, so if you look at this guy, what can you tell me about the sign of this guy? What is it? So what did we say? So this part is positive. What about this part? What is the sign of that part?
Negative.
Do we know? Is it always negative? No, right? In which case it's not negative? If it's a given good, we said it could be positive. But suppose it's not a given good, mostly this part is negative, right? Mostly. That's what we said. So that's why mostly this price elasticity of demand, so let's say except for given goods, okay? This is negative, okay? So let's actually consider this guy. So let's say note. So basically, if this price elasticity of demand, okay, is less than -1, meaning that it is a number like -2, -3, okay, -4, then we call, in this case, we said that demand is what? Demand is elastic, right? And in Econ 101, usually we take the absolute value of it. So when it's a bigger number, we call it elastic. But here, because it's a more negative number, we say it's smaller, but in absolute terms, it's actually a larger number, right? As I said, -2, -3. So demand is elastic, okay? So for instance, mostly goods that are not necessities would give, their demand would be elastic. So do you think that caramel macchiato's demand is elastic or inelastic? Elastic, right? So it's not hopefully it's not a necessity. Some people it might be, right? So, or, you know, like you can have cars, furniture, you know, like these kind of, and many goods that you can, caramel macchiatos and such. So here we said that goods that are not necessities. Okay? Now, when we have this guy equal to -1, we actually said that demand is unit elastic. Meaning, what does this mean? For instance, what does this mean? It means this. Suppose it's -2. It says that when there's a 1% increase in price, actually the consumption of X is going to decrease by 2%, right? So because if it's -2, then if this increases by 1%, this is going to decrease by 2%, okay? So when there's a change in price, quantity responds more than the change in price, okay? That's why we call it elastic. It's very responsive, okay? Here, it means that when there's a 1% increase in price, then quantity demanded would decrease by exactly 1%. So this is actually an empirical phenomena, and then people check. It turns out that grapes, you know, like you should check it. You should go to data and check. So these numbers, remember I told you we have seen all these theories, but at the end of the day, later you're going to see that because this X star, for instance, think of Cobb-Douglas, depends on alpha beta, then this elasticity number would depend on alpha beta. So you have to go to, in order to compute that, you have to, you know, get somehow estimate this alpha beta from the data. Wow, so it's okay, so it's you should get those parameters. You should estimate those parameters from the data so that you can actually give these kind of important numbers, for instance, to those firms. Okay, so and when they do it, it turns out that you know, like the demand for grapes, I think the demand for Coke, it's unitary elastic. Okay, so then it's the last one is when this is greater than -1, meaning that it's -1/2, -1/3, etc. We actually say that demand is inelastic. Okay, so mostly these are goods that are necessities, goods that are necessities. Okay, so what they are, so usually goods that where we have, for instance, bread, right? Of course, So, but there are actually interesting goods as well. For instance, rakı, beer, okay? So, cigarettes. So, for instance, basic clothing, not your fashionable, clothing that you would get from, like these fashionable stores, but the basic clothing that you would have, right? You would think of the necessities, water, and such. But you see, actually, this tells you something. Demand is inelastic. Apparently, what does that mean? When you change the price of that good, quantity demanded of that good, let's say by 1%, it's going to decrease by what percent? Smaller, right? So it's going less than 1%, right? So this is actually very important. As I said that, even though this course might not be, like includes hot topics as much as macro, it looks as if. But for instance, here with these concepts, these are very important. For instance, you can actually say these kind of stuff. So apparently when for instance, what does this mean? If I put a tax on rakı, if I put a tax on cigarettes, do you think it's because I want to decrease their consumption? Can I do that according to this if their demand is elastic? So why are they doing it? To get money. Okay, so this, or those poor guys, right, with those fake alcohols, that's what they were saying, right? Please, decrease the price of that good. Why do you think that guy was saying that? Because no matter how much increase you're going to introduce into price, via taxes and such, as your friend said, that he's going to drink it, right? İçecek yani, he's going to drink it. So it's not elastic, right? By changing price of the good, you cannot change the consumption of that guy that much, okay? So that's why whenever they put, tax on cigarettes, whenever they put tax on rakı, whenever they put tax mostly on nuts, so you can actually say that this fancy and imported alcoholic drinks, tequilas or, like whatever, those are, on them you might actually see that demand is a bit more elastic. But on rakı, beer, demand is inelastic, okay? By putting, like whatever tax, it's very hard for you to decrease that demand, okay? So that's why you see micro is very important, that you have to know these numbers, right? And you have to act accordingly, okay? So now that's a hot topic, thanks to, but it's very sad, obviously, to those guys. I don't want to say. Yes, of course. So it's you have to have other policies, right? You should have maybe, like these celebrities saying that, oh, don't drink, whatever. You have to change. You see the functional form, right? The utility function of those guys. Because in the current stage, apparently, whatever tax you put, he's going to drink it, okay? So basically, that's actually it. So let me actually write this down. So this is what we have, so just keep in your mind. So whenever there's a tax issue, always keep in mind that whenever, for instance, do you think when they put tax on cell phones, they are also, like it doesn't affect that much the consumption, right? So it's, of course, not as much as probably rakı and other stuff, but that is the case, okay? And let me tell you another thing. So you see as I said, the beauty of micro, okay? So that we can actually, starting from here, we can even say something about the current account. You know what current account deficit is? Nedir? Hep duyuyorsunuz değil mi? Cari işlemler açığı. Cari açık. So at some point, okay, and you can actually think of current account in very, like basic, so let's call this the current account deficit. In very, like basic terms, it's like your exports minus your imports, okay? So it's like whatever goods, the value of the goods that you export minus the value of the goods that you import, okay? So when they were putting all these taxes, like to actually these drinks, to these cars, right, foreign cars and cell phones, one of their claims was actually to decrease the current account deficit. So the whole idea is because when you put the tax, you're going to decrease the demand, right? That's the whole idea. You put the tax, people are going to consume less of these imported goods, right? And then, because this goes down, even if this stays the same, then what's going to happen? The current account deficit is going to shrink, right? But you see how important the elasticity is. If you want to decrease the current account deficit, if you put the tax on, like let's say cell phones, and if you don't have a, domestic sort of replacement for, Apple, Samsung, LG or whatever, then what's going to happen? It's not going to decrease, right, that much of the demand. So you have to know the elasticity, right? The total demand for that good, it's not going to decrease it that much. And at the end of the day, you're not going to shrink the current account deficit, but you're going to get some money for the treasury, right? So whenever they put a tax on any of the goods, just keep in mind that these guys are, are putting it either to collect money or they really think our benefits, okay? They would like to decrease either our consumption of rakı or they would like to decrease the current account deficit, right? So make sure that you see that it's very important, even though this looks like a very abstract concept, it's crucial for this policy to have an impact, right? The desired impact on the society, okay? So just keep this in your mind, it's very important. Even though elasticity looks very abstract, it has lots of usage and it has an important meaning, okay? So let's continue for the second hour, okay?